dt, that is equal to s into f of s minus f of 0. In this particular equation, we try to assume that s tends to 0. So if that is the case, 0 to infinity, f dash of t, here becomes 0 dt, s into f of s, we can say limit s tends to, we try to substitute s tends to infinity. So this is going to be minus infinity and s tends to infinity minus f of 0. So this part is going to be 0. So this particular e raised to minus infinity is going to be 0. So this side is going to be 0. So that is equal to limit s tends to infinity s into f of s minus f of 0. Therefore, initial value f of 0 is equal to limit s tends to infinity s into f of s. So this is called the initial value theorem. So according to initial value theorem, the initial value of a function is given by s into f of s limit s tends to infinity. There is another important theorem, which is the final value theorem. According to final value theorem, the final value of a function is given by s into f of s limit s tends to 0. So we'll apply the same rule. Laplace transform of f dash of t is equal to s into f of s minus f of 0. Now we apply the basic definition of Laplace transform, that is nothing but 0 to infinity f dash of t e raised to minus st dt, that is equal to s into f of s minus f of 0. Now in this case, we are assuming that s tends to 0. Earlier we have considered s tends to infinity, but in this case we are considering s tends to 0. So this equation becomes f dash of t e raised to 0 dt is equal to s into f of s minus f of 0, here limit s tends to 0. So this part is 0. Then we have integration of f dash of t. If we integrate f dash of t, we will get f of t with the limit 0 to infinity. That will make you limit s into f of s tends to 0 minus f of 0. If we substitute upper and lower limit, we will have f of infinity minus f of 0 is equal to limit s tends to 0 s into f of s minus f of 0. So these two terms cancel. Then we will have the equation f of infinity, which is the final value, is equal to limit s tends to 0 s into f of s. So just to summarize the different equations or the different Laplace transform equations that we have seen today. The first is the basic form, which is Laplace transform of f of t, obtained by the equation integral 0 to infinity f of t raised to minus st dt. Is also called f of s. Then Laplace transform a constant, k by s. Laplace transform of t 1 by s square. Laplace transform of t raised to n factorial divided by s raised to n plus 1, where n factorial is nothing but 1 into 2 into 3 into etc. up to n. Laplace transform of e raised to minus at, it is minus here, so this is 1, the answer is 1 by s plus a. Laplace transform of at, we are multiplying by the term at, positive at, so we have to do the shifting in the s domain by s minus a. Laplace transform of cos function s divided by s square plus omega square. Laplace transform of sine function omega divided by s square plus omega square. Laplace transform of a composite function e raised to minus at f of t f of s plus a, e raised to at f of t if f of s minus a. Laplace transform of derivative of a function s into f of s minus f of 0. Initial value theorem. F of 0, the initial value of a function is given by s into f of s limit s tends to infinity. Final value theorem, s into f of s limit s tends to 0. Thank you for watching this video, and we'll continue more complex Laplace transform equations in the next lecture. Thank you.